Let's start with how high LOI ore silently degrade the blast furnace permeability. Four mechanisms are at play: low temperature disintegration, thermal shock from water vapor, phase changes, and premature slag formation that we have already discussed in the earlier presentation. Together, they generate fines that reduce permeability by up to 30% as it's shown in the slide. Now the maths which works is like this. The pressure drop, that is delta P, is already shown, already calculated, which is uh, given as per the formula in the slide, where K is 0.03 to 0.05, and for every 1% LOI above 4%, fines increase by 2%. So every 1% LOI above 4%, fines increase by 2%. So if you use 30% high LOI or expect a 0.24 kPa rise in pressure, which is enough to destabilize the blast furnace burden movement, and further there is a huge process upset. Now coming to the high LOI effect, pellet formation and its consequences. So if we come across the high LOI effect, pellet formation, there are two ways. The first, it absorbs excess moisture during a granulation, weakening green pellet strength by 15 to 25%. This is one of the highest impact. As for the second is concerned, it disrupts granulation dynamics, that is the disk RPM, retention time, and particle size all become unstable. And also during firing, water decomposes at 327 degrees centigrade, as we all know, these creating a internal pressure and micro crack. Already literature shows that pellet with a LOI more than 5% had a RDI value jump from 8 to 15%. So, a conclusion is or the message is very clear. LOI directly impact pellet durability and furnace performance together. Now, coming to the tumbler index measure and its dependency on the pellet strength, here the trend shows that LOI wherever is less than 2.5%, and TI is in between 90 to 92%, which is excellent, and LOI where it is more than 5.5%, TI dropped to 80 to 84%, which is pretty poor. And to counter this, we need to adjust the firing temperature for LOI 2.5%, firing at 1330 degrees centigrade. And if LOI goes on shot up to 5.5%, then we must have to reduce these firing temperature to something almost difference of 100 degrees centigrade. Now these strategies helps in preventing crack and improving the cold crushing strength, which is a huge gain. And as a formula also shows that the lower LOI and higher tumbler index and CCS, it result. Um, and as far the cost is concerned, almost we can say 500 to 600 Indian rupees per ton extra is to be incur for this. Um, but this only suitable for enabling use of low grade ore. This is how it is a way out to utilize our bad ore which have got a higher LOI. Now coming to the LOI effect and its reducibility and swelling. Uh, as we know that all LOIs are not equal. Type A goethite rich ore reduces easily, where Ri up to 75%. Now, if we consider type B ore, hematite with the clay moisture reduces very poorly and Ri drop to only 68%. So, mineralogy matters. For RSI, where hematite LOI is 2.5% and RSI is 8 to 12%. Whereas if we talk about a goethite where LOI is 6%, RSI is 15 to 20%, limits high LOI ores to 20% of the burden to avoid excessive swelling. Now to reduce LOI before pelletization, use jigging. Here are the four-step process: crush ore to liberate clay, jigging separate heavy ore from light clay. LOI drop 30%, wet screening removes fines. LOI drop another 15%, dry screen to final size result. So cleaner ore, lower LOI, better pellet performance can be derived. Adding MgO 4 to 6% to high LOI ores forms magnesium ferrite, melting point 1770 degrees centigrade. This reduces liquid phase and RSI. Uh, Meisteel saw RSI drop from 18 to 12%. In the furnace, high LOI shift the cohesive zone downward and widen it. This affect the slack flow and the refractory wear. So MgO not only improves pellet strength, but it also stabilizes the furnace geometry. So this is also a methodology to combat the LOI issues. Now coming to the lowering of firing temperature and saving the fuel, each 10 degrees centigrade drop is equivalent to 2% fuel saving. And from 1330 degrees centigrade to 1220 degrees centigrade, 2.2% saving. That is 35 ton gas per day at 50 ton per hour rate. So this is the evaluation based on those reference value. Now coming to the fluxing option, MgO 2 to 3% leads to RDI improve by 4.5%, a point rather. RSI drop 6 point CAO, self-fluxing and less effective but cheaper. Net benefit is MgO saves around 50 to 70 Indian rupees per ton in the furnace cost. So there is a benefit. Now coming to our golden rule that if LOI more than 5%, limit to 20% of the burden, blend with 35% center, LOI if remains in between 2 to 3%. 30% low LOI pellet, 15% premium Lampor, adjust Fe by C ratio, hot blast temperature and enrichment to stabilize the reduction. This keeps pressure rise less than 0.16 kPa and fines less than 3.6%, which is within the safe limit. And in our earlier discussion also, we know within this band furnace can be operated effectively. Now coming to our final takeaways, which is talking or derived the about the LOI effect, which everything and it contribute a lot in the furnace operation from pellet microstructure to hot metal quality, but it is manageable. Use beneficiation, MgO fluxing as we have seen, temperature control and smart blending in the last slide what we have seen. The may still save around we can say 200 million rupees, Indian rupees we can say, per year using MgO bearing pellet. And LOI optimization support green steel, especially hydrogen DRI. So don't reject high LOI ore. We have to engineer them, and if once we engineer it properly, it will work well.